Hey, we have here today another integral from the UNT Integration Bee. This was sample problem number 20. We have the integral of x squared over x squared plus 8 all to the 3/2 dx. Okay, it could be a little intimidating having this 3/2 power here and even having like a x squared in the numerator there. But based on what we have here, this seems to be a classic case where we want to use trig substitution. And this is going to be the case where we want to use tangent. So what I'm going to do is I'm going to call my x equal to square root of 8 tan of t. I do that because what we want is we want a squared term here. So we can write 8 as square root of 8 squared, and that's what's causing me to use a square root of 8 right there. I'll take my derivative. So our dx value is going to be square root of 8 secant squared t dt. And I think while we're at, okay, let's look at our x squared. X squared is just going to be 8 tan squared t. So when we look at this x squared plus 8, that's going to be 8 tan squared t plus 8. Now we can factor an 8 out of this so that we just have tan squared t plus 1. But tan squared t plus 1 is just the same thing as secant squared, so we can, for this expression, we can write this as 8 secant squared t. Okay, so now I'll go ahead and make this substitution. So for x squared, we already found that value, so we're going to have 8 tan squared t dx. Where's our dx? Okay, square root of 8 secant squared t dt. Then for the denominator, we have for x squared plus 8, we've got this thing, so we have 8 secant squared t to the 3/2. Well, from here, let's just focus on these 8s for a second. So if we put these together, we're going to have 8 to the 3/2 in the numerator, but we also have 8 to the 3/2 in the denominator, so what I can do is just cancel all these terms with 8 in it. And then I can take my 3/2, distribute it in here, and then when I distribute these powers, and the 2's are going to cancel, and we actually have secant cubed here. So if I do the rewrite, we have our tan squared t. Now, if this is secant squared t and this is secant cubed t, that gives me a secant t in the denominator. Let's take this into the numerator and write it as a cosine t. And then from here, what I'm going to do is I'm just going to write this in terms of sines and cosines. So we'll write tan squared t as sine squared t over cosine squared t. And then what that's going to do is allow one cancellation here. And then what I'll do with sine squared t is write it as 1 minus cosine squared t. But then with the minus sign here, what I can do is just split this into two integrals. So the first one, 1 over cosine, is going to be just secant t. And then for the other one, we're going to have cosine squared t over cosine t. One cosine is going to cancel, and we're just integrating cosine of t. Sorry, I forgot a dt right there. Well, secant's a very well-known integral. This is just going to be natural log absolute value secant t plus tan t. And then integrating cosine t, that's just going to give us sine of t. Okay, now from here, all we need to do is get this back to x to finish it off. And what we'll do is we'll go back to this definition that we set originally. But I'm just going to rewrite it a little bit. Let's divide by a square root of 8. So we have that tan t is going to be x over square root of 8. So then when I draw my right triangle, the angle here is going to be t, x over square root of 8. So we'll have x, so opposite over adjacent, x over square root of 8. Then with the Pythagorean theorem, we can just find this hypotenuse is going to be square root of x squared plus 8. And then with that, we can find all the values we need. So let's just put them in there on the fly. So secant is going to be hypotenuse over adjacent. So our secant value is going to be square root of x squared plus 8 over square root of 8. I'm doing it this way because we know that our tan of t already has square root of 8 in the denominator. So this is going to be an x over square root of 8. And then our sine of t is going to be opposite over hypotenuse, so that's going to be x over square root of x squared plus 8. And this is fine, but you'll actually notice that square root of 8 in the denominator, we could use log properties here and split this into 2. So then we'd be subtracting natural log of square root of 8, but that's a constant value, and we could just absorb that into our plus c over here. So this is going to go into here, but what I'm going to do is just delete that because we don't need this square root of 8. But then also, let's just notice that this value inside the absolute value is always going to be positive. So what I'm going to do is let's just delete that right there. So for our final solution, we have natural log square root of x squared plus 8 plus x minus x over square root of x squared plus 8 plus c, and that's it.